A little while ago I did a video on PCB engraving. I needed to make a PCB. I didn't have time to ship it off. So I talked about, showed how to develop it, build it up in Fusion 360 as basically a 3D CAD model, and then go ahead and take it to the mill and engrave it. So that worked out really cool and I was really happy with it. And then I decided to sit down and go into KiCad and create a real one that I would send off. And now I've been going to Osh Park for a very long time, and I still love them very, very much, but and I've always been really happy with them, but I wanted to give Seed Studios a try, and so here you go. So you should check them out. So what I did is I went to the website. A lot of people online, they've been talking about them for a little while. And so you go there and you check it out, and it says, okay, well, make your board, and it's going to be $4 and some cents for 10 of them. $4 and says it 10. So I was like, whoa, okay, wait a second. Is that 10 or $4 a piece and 10 minimum? Or that's going to be $40? Well, how does that work? No, it's $4. And then they charge you shipping, which ends up being about 20 bucks coming from China, but still 10 boards. I think I paid, grand total was a little under 30 bucks or something. So I'm pretty excited about this. I want to open this thing up. I was going to just rip and tear it open, but I figured I better do it on camera just so I could, I don't know, get first reactions on it and let everybody see how it goes, I guess. I hope it's not poo. I hope I didn't get poo. So by the way, this did take, well, honestly, you know what? I have another order on its way. I did a thing the other day. I had a board, what the hell was I making? I have another board that I shipped off, but I shipped off, I did a set of your default 3 through Osh Park, and then I did another order of 10 of these through Seed Studio. And I want to see who gets here first, and you know, and how the whole experience goes. The reason I say that well, the reason I'm doing that is because I ordered these just a little bit or right into Chinese New Year, and so that was basically you know, everything's shut down there. So I honestly don't know how long it took. The date today is the 7th of March. So you go figure that out. You know, at the end of February they get done with Chinese New Year's. It didn't seem like it took very long. So far so good. So here we go. Seed Studio. Oh look, it's all bubble wrapped in, oh yeah, this is great. This looks good. Hopefully I'm not doxing myself with Chinese characters right there. But look at that's pretty good. Huh. Okay, let's rip this open. You can kind of tell, well, here you'll see in a second here. When you go there, part of the thing that's kind of neat is, as much as I like the purple PCB, yeah, maybe I am one of those guys that likes the purple PCBs, I like the fact that through Seed Studios you can pick colors. You can pick, what were they? There's about 5 different colors. Red, maybe there's yellow in there, possibly. Green, of course. I went with black. It does appear to be a gloss black. I know Dave on the EEV blog hates black solder masks, so sorry Dave. I think these look pretty nice. This is pretty cool. Let me, well, I guess I need to show you guys, but I want to look at them too. They're all great looking. Huh. Nothing I could say, you know, not that I can necessarily be an authority, but I do have, I don't know, I have, you know, piles and piles of, you know, bags of circuit boards around here that I've ordered. So, you know, I've been doing this for a little bit now. Again, not saying I'm good at it, but I do a bit. So, what this is, so for those of you, if you want to check out the other video, there'll be a card up there. This is a solder prototype practice board that I developed for some classes, and the idea is to have something that is like a breadboard, something that's like your default, you know, kind of strip boards and perf boards, but with a little bit of a purpose. So right in here, this is for an Arduino Pro Mini, so you can stick this right on the side here, and then the programming headers will be right off the side, so it'll be easy to plug in. Sorry for the light shining on there. I don't know. Yeah. I don't know which way is going to be better. So the legs programming headers will be over here, And then down here you have your power and ground. And then what I've done, let me grab a poker. The idea was that, say you're going to put, you know, in any kind of perf board or something, you're going to stick a component in, and then you have to bridge the solder joints, bridge the pads over, and that's okay. But I thought for ease of simplicity and all that, you know, for new people, what I would have people do is you could plug in your component right here, like one leg, say it's an LED, a cap or something. This one is tied to this one is tied to this one. So if the cap goes in here or the LED goes in here, then you'll be able to solder on to over here another wire, jumper wire, and fly it over to wherever else you need it on the board. The other intent with this was to not make a project board, not to make this be a project for an Arduino, but to kind of, you know, but to let you do whatever you wanted to do with this, right? But at the same time, create some intentional, you know, like one thing I might do is say, I want you to wire this LED over here, but I want you to go from here to here to here to here to here to here to get over to there to do that. Maybe something like that. Again, just to practice soldering. Soldering of different types. So then here's my next point. So you got a whole bunch of, you know, wires and tinning wires and through hole and all of that. And then maybe in the course of this, you might even do some tying wires together, which you should do if you're doing any kind of practice like this. Practice tying wires together, doing the kind of a lineman's knot, or somewhere along the way I thought I heard Westinghouse knot, but let's say lineman's knot, where you tie it together, the solder joint like this, the wires, and then you solder it and then shrink wrap it over there. Use your flux and everything for tinning, but make sure you clean it off, you know, so that, well, one, besides, you know, all the corrosiveness and potential connectivity problems and all the other kind of things like that, it just is sticky and goopy. And if you're using shrink wrap that is it's got adhesive or anything on it, or just any kind of shrink wrap, shrink tube, it won't stick if you got a lot of flux in there. Anyways, tangent, sorry. So then the other thing I have on here is I decided to place in some surface mount components because I wanted people to practice this. And it sort of seemed to me that, you know, all these electronics classes around, they all do these through-hole projects. They do these Velleman projects that have been around since what, the 50s, 60s? I mean, these things have been around a really long time, and I do not want to knock them. You know, these are the things that we all got our start on. These are the things that we all work and play with. You know, I'm a little kid and I'm getting stuff from Radio Shack in boxes. There was these little plastic boxes that had these holes on the top that was kind of like a breadboard that you would end up putting all your components through and then soldering to the backside. And so then the lid of the box became your it was your project. That was your case. It was cheap and easy, and it was pretty cool, and it was the same sort of stuff. But anyways, the modern age for, like, oh, I don't know, you know, pretty new, you know, like only what, the last 20 years has been surface mount components. So getting people to learn all that I thought was very important, and so then I added these in here as well. Then another thing that might be a little bit more you know, asking for much here is there is a bit of a project that kind of goes along with this, and it has to do with a strip of the addressable LEDs, the NeoPixels, and they need to have some power. So your power comes in over here off of some type of battery. So then you're going to have a regulator right here. You're just going to have your regular old T220 stand up, right? And just let it hang around. You know, it's not that big of a deal, I don't think, right? And then I have another 3.3 volt regulator surface mount that's going to end up hanging out right here. Then we have another little chippy and some other little support components, some pull-up stuff and what have you, because what I want to do is this project that we work with for, this is for, just to be specific, one of these things that I'm making lately, there'll maybe be a video. I have an Instagram of the same name of the channel, .dissonance. You can go check that out. But I've been making snowboards for like the past 10 years. I have a company on it, sacrificial boards. I don't do anything with it anymore. Anyways, it's around, right? And so anyways, last season I made some lit boards, and people have been doing this, right? But the deal here is I've also been doing composites for a very long time. And so, and mold making, material science, and all of that. So what we do is on the mills, holy crap, on the mills that I built, because I also make CNCs, I have a long mill that I made that I was able to mill out the trough for a mold for the sidewalls of the snowboard, and then embed the neopixels, the lights, inside of those. Then you have a control box that's very much like this that ends up going inside of it that you use to control the lights. Well, one of the things that you stuff in there is one of the LIS 3DH accelerometers. And what you can do then with that, you know, it's up to you however you want to program it, but the idea is then you can program the lights to do different types of things depending upon what you do. You're going faster, you're spinning around, maybe make the lights blink around, you slam really hard, you hit really hard, you do a big jump and land, boom, the lights go crazy, right? So I thought that would be super duper fun. So I want to put one of those modules on here, but then I thought, well, you know what, you know, and again, like I said, it might be asking for much, and I could have this wired all wrong, but I looked at a few different schematics online, SparkFun, Adafruit's version of it, and of course the application, typical application circuit in the white paper for this. This is that right there. So I copied the best I could this circuit, and I'm hoping that this works. If the circuit works, then this is going to be a pretty fun, cool little project to be able to put together, learn, practice soldering, and get something kind of interesting out of it. So it will be an Arduino Pro Mini with power input for a battery if you want to keep it off of the USB, accelerometer built in. Oh yeah, and by the way, over here is some resistors and some surface mount LEDs. Some Cree LEDs will go right in here to show people surface mount, and holy crap how bright a Cree LED is. And then, you know, again, like I said, the reason to solder everywhere all over the place. And oh, and then somewhere down here, you know, you have a strip of neopixels, so when you wiggle the thing around, you can make them light up in different ways or make these flash or whatever. So if you've never done anything like this before, if you're still watching this and you like this electronic stuff, but you've never done this before, you need to give this a shot. Just jump in and give it a try. For 30 bucks, who cares if it works or not? You know, just try it. Try the whole process. So go get yourself a copy of KiCad, KiCad, however you want to say it. It's free. Go get it. Learn it. A lot of videos out there. Chris Gamble, he did a whole series on this a while back, and that was pretty cool. I have some videos from, like I did last year or so, on this just crazy rants of projects that I've been worked on, but there's a lot of stuff out there. Figure that out. Then go find the, you know, the PCB manufacturer of your choice, you know, Seed Studios, Osh Park, on and on and on. So go find those things. But see, then the other thing that's cool that I really like about this reality of, you know, building a thing all the way through to in your hand and done, is in order to make all these tabs and trees and all these footprints on here, of course, you've, like I said, got to go get the data sheet. So you go get the data sheet and you figure out what you want, but where did you get the data sheet from? Well, you found it online somewhere. Is that the product you're going to get? Well, I'm going to go get this little chippy, and it's like that, I think, right? No, you need to go find the right one. And so the right one you're going to get is really the one you're going to go get. So what I mean, you're going to go to mouse or a DigiKey. You're going to find your part, the one that you want to use, and that's going to take you a few hours probably right there to find it. Once you have it, then you get that data sheet, then you make your footprints, and you get that on here, and you just take a breath, and you take your time, and you get it done, and you do your footprint, and then maybe the next day you do another footprint. Eventually you get the thing all complete and everything where it's at. You get your board built. You go through the wiring of the thing, the routing of the thing, hand routing, right? Go through the hand routing, and wow, that'll be a thing that you'll learn there. And then you can ship this off to the board house, and then you get this, and then you get this, and then you get to solder it. Then you get to solder, put it all together, and then, you know, maybe it works, right? Isn't that cool? So that's what I wanted to share with you. So that's it. I'm really happy with all of this. It's just a really cool time to be working with stuff. I know that probably every caveman in the world said, what a great time to be alive, but I mean, this is really pretty cool. It wasn't that long ago that I was etching my own boards, and I thought that was neat, and then I sent out for, I think it was just 2 of them, and it was about $100 and some for the set, and I didn't even get solder masks. They came back pretty crappy. So thank you, Seed Studios. This worked out really well. I hope my next project is equally as good. Very excited. Thanks everyone. I thought I just wanted to share that with you, and hope you found that interesting, and maybe you go give this a try yourself.